So welcome everyone to this seminar. I will go straight to our speaker, who is Kathryn Piquette, Dr. Kathryn Piquette. She has a PhD in Egyptology at UCL, University College London. She has been working for quite a long time with RTI. I always have to read the acronym, which is this technique of imaging called Reflectance Transformation Imaging. And she will show us today her work on the Herculaneum Papyri and Greek magical texts. Kathryn is now working for Cologne at the Center of Key Humanities as a research fellow, associate, and I will just leave it to you. There is an attendance list circulating, just make sure you sign up and also leave your address if you want for the mailing list.
Great,
Please.
Thank you. Good evening everyone, and thank you for coming out on a very cold, increasingly snowy night. It's a real pleasure to have this opportunity to tell you a bit about my latest adventures, my latest work with RTI, and to come back to Berlin, where I actually was studying or doing research with a Mary Curie Co-Fund Fellowship, studying early Egyptian writing and Near Eastern writing and art for a couple of years. So it's great to come back. And then I've moved on to other things through some great projects at the University of Cologne that I'll tell you about tonight. So how I wanted to structure our seminar this evening is in 3 sections. So first, starting with the Herculaneum Papyri pilot imaging project. And I'll talk a bit about some of the RTI tests that I did last year, introducing infrared illumination into the RTI capture process. And we'll look at a couple of examples of those results. I will, for those of you who might not be so familiar with RTI, I will intermingle in that discussion a bit more about how RTI works, what it is, why you want to use it, how you use it, equipment, processing, that sort of thing. And then I'll move on to the second project I'm working on, which is Magica Levantina, which deals with Greek magical texts together with my colleague Robert Daniel and Alex Holman. And I should also say that the Herculaneum pilot project is something that I've been working on together with Jürgen Hammerstadt at Cologne. So with Magica Levantina, I'll talk a bit about some of the challenges that one encounters when trying to image metal, and in this case lead, as well as a kind of mineral called selenite or gypsum. And then drawing from these 2 projects that I've been working on, I wanted to say a bit about how we conceptualize the digital image, the way in which we use it as a resource or as a product as a result, but then also how it's a very active, subjective thing, and how it's important to sort of realize how it fits into these processes of its production as well as use. And that's something that I'm increasingly, I had been researching in terms of past image production, past image practices, how ancient scribes and artists would make images. But now that I'm working so heavily with modern imaging technology, I'm starting to think, and maybe this is something you've already given a lot of thought to, and I'll mention a few other people who have, but how we construct digital images and the importance of being aware of those processes. So, so to kick off with the Herculaneum Papyri, you may be aware that these texts were preserved through a very dramatic event, the eruption of Vesuvius in 79 CE. This is the largest preserved library from the ancient world, comprised of about 1,800 papyrus rolls. And those that have been read so far tell us that these deal mostly with Epicurean philosophical treatises, and they're written in Greek for a large part. So we've got an image here of the villa, a reconstruction of the Villa dei Papyri at Herculaneum, an indication of where the papyri were found approximately, and then I've got a couple images here showing what they look like when they're rolled up. And if you've been paying attention to technology news, you will have seen that there's some really exciting stuff happening with trying to read these rolled up scrolls, these rolled up texts using a synchrotron at Grenoble, and a team there is finally not only able to distinguish the actual layers inside a roll, but start to actually read the carbon ink on those layers. So this is a massive breakthrough, very exciting stuff. But what I'm going to be talking about is dealing with the unrolled fragments. So this is about 1,800 of the rolls have been unrolled via a technique that, see if my pointer is working, you can see a reconstruction of the sort of machine that was used to do this we're talking the 17 and 1800s when these were carefully, the rolls were carefully cut off layer by layer and attached to animal gut, and then mounted on card, as you can see here in this papyrus tray. So this is what they look like originally. These very crumpled, distorted rolls. This is just what happened when the pyroclastic flows and the heat hit them, and they've carbonized in a way that's very difficult to then unroll and get nice flat even papyri. And a lot of the scrolls have been lost through attempts to unroll them. But you can see how complex they are. So if you're familiar with, most of the papyri you probably have worked with or seen is very nicely, laid out, very flat. So this is a very different kind of physical object to deal with. And here's just a close-up shot that I hope can help you sort of appreciate how complex they are. We often think of texts as being sort of two-dimensional objects, but these are very emphatically 3D. Lots of crumpling and distortion, layers sticking together. So while you can see, and this is a photograph with visible light, and while you can just see some of the ink on the surface there, you can see that a lot of information is lost in the undulations, in the self-shadowing. So methods that have been deployed thus far to try to recover the writing on these scrolls are hand copying. So what is visible to the naked eye, often using with the aid of a microscope. So you'll see the papyrologists down in Naples sitting in a room with their microscope, sort of tilting that papyrus laid out on that mounting board underneath the microscope, trying to get the light in just the right position to read whatever is visible with visible light. That sort of work has led to these hand copies, these disegni, which idealize the text a bit, try to sort of flatten it out and order it into these columns and rows. And then, of course, conventional photography, both analog and digital. Conventional meaning fixed light with visible light. And then more recently, in 2000, Brigham Young University went out to Naples, and a team worked for a couple of years, took over 30,000 photographs using multispectral is probably, well, not the right term, because in fact they found that the ink responded best to infrared and certain wavelengths. And so really it was infrared imaging that was successful in capturing the majority of the texts. But infrared, visible, or ultraviolet, this is if you're not familiar with the electromagnetic spectrum, I just put a visual up here to give you an idea of what we can see with our eyes. And then it's this infrared wavelength, series of wavelengths where the Herculaneum Papyri are responding best. We're getting the best contrast between the blackened carbonized rolls and the black ink on them. So infrared imaging, including the photography, reflectography, and transmitted, are ways of also recovering text from a range of objects, but in this case, the papyri. So the infrared photography really was a leap forward in 2000 for the community in terms of improving legibility. So this is an example of one of the Brigham Young University where the images are all stitched together. And you can see from this close-up the extent to which the text is visible. But it was really early last year that after Jürgen Hammerstadt had seen some of the work I was doing for the Magica Levantina project, he suggested that RTI might be able to improve on these results and address some of the problems with these infrared fixed light photographs. And having actually come out to Berlin in 2011, and I don't see Verena. Lepper here this evening to do some tests for her. She was trying to put together an imaging project to see if RTI was of any benefit. We sort of determined that it wasn't really going to be helpful for the kinds of research questions she had for increasing the legibility, just visible light RTI. So based on that experience, I had sort of thought this wouldn't really lead anywhere, but I was happily, pleasantly surprised that RTI could contribute because of the physicality, because of the these are very three-dimensional objects and the problems of things like self-shadowing. So so some of these problems that that these albeit wonderful infrared images they do a great job. Nevertheless, because the light is fixed, the nature of infrared photography is that the surface appears very flat. And when you're dealing with this kind of undulating topography, various problems arise. So, for example, holes will appear black, but of course the ink is black. And so if you have any small holes that might sort of appear similar to the shapes of characters, the shapes of signs, or might enhance a sign with this shape, and then you have a hole in the middle, and you might think you're dealing with a different letter than in fact was originally on the surface. This is kind of obscured by this type of photography. Details can also be obscured by self-shadowing. So in this smaller shot here on the right, you can see that there is information that's just lost in shadow because of the curvature of the surface. There are also, as these things were unrolled, sometimes layers stuck together. So it's important for a papyrologist to be able to count the layers, to understand where they are within the scroll, and to try to understand the relationship between different layers. For example, if you have text that appears continuous, but in fact it might be on two different layers. So being able to count the layers and see the edges is very important, but this is sometimes lost by the flattening effect of fixed light photography. There's also the issue of some pieces of papyrus being, as the scroll is unrolled, you might have a hole, and the piece of papyrus that fits in that hole might either be lying further along or further behind where it actually sits. These are called sottoposti and sovraposti, and it's quite important to be able to reconstruct where these little bits that have been stuck elsewhere, where they actually fit. But to do that, you need to be able to see the edges and be able to really characterize their contours to put them in the places they belong. So that's been a bit of a challenge. And then registration, also getting images to align properly. And some of this has to do with the technology that was available at the time, the resolution of cameras and lenses, and the time available to undertake the work. So these were the kinds of things that we wanted to visit with a couple of pilot tests last year to see if we could improve on these previous results. So 2 phases. The project had 2 phases. I went out in February and just did visible RTI, highlight RTI, which is a manual method. I'll explain a bit more about that in a moment. But you can see this setup here on the right where there's a camera fixed on a tripod. This is actually, in this shot, I'm actually doing infrared RTI. But this is just the basic. It looks very much like normal photography, but there's a difference in that you're applying the light from different positions and taking a whole series of photos. But I hadn't really worked with infrared or any sort of multispectral imaging prior to this time. And so visible RTI was all I knew. So when I went out, that's what I did. And we determined that we were able to enhance some features, but we really needed to be able to combine infrared with the highlight method. So our aim in conducting these 2 pilots was to increase legibility through virtual relighting, the ability to relight the surface, and I'll show an example of what that looks like in a moment, but also to clarify physical structure. So as I just mentioned, so these sovraposti, sottoposti layers, being able to clarify those physical attributes, and then to trial infrared light emitting diodes, LEDs. And the reason for this is that non-LED light sources put out a lot of heat. And so this was a way of trying to avoid accelerating thermal degradation. And this is something that Eleni Kutula at the University of Southampton, among others, she was working on it for her doctoral research, and others have been looking at ways of applying a cooler light source, because we're dealing with very fragile, very fragmentary objects, and we don't want to sort of recarbonize these already very, very fragile objects. Also, they're so thin, and I'm also concerned, I don't know how realistic this is, but that they could actually start to, under heat, could start to fluctuate and move. And with taking on humidity from me, and depending on, we're in Naples, the Bay of Naples, on the seafront there, as the weather changes, these thin, kind of gossamer fragments could start to sort of change their shape. And it's really important while you're doing the photography that they are absolutely stable, absolutely still. So putting a hot light source on them, it's bad for a variety of reasons. So testing the LEDs was quite an important thing. And this work was a cooperation between the University of Cologne and the Biblioteca Nazionale di Napoli, which was they were really, really wonderful, really supportive in trying out undertaking these 2 pilot tests. So here's one of Brigham Young University's wonderful stitched together images, and I just want to show you one of the infrared RTI results dealing with this upper right-hand corner area. So what I did was, to get high spatial resolution, I actually was imaging in smaller sections. So just by raise of hands, how many of you have undertaken RTI or worked with RTI results? A couple. Okay, so it's a relatively new technique, yeah? All right, just so I know how much to explain. Yeah, please, thank you. So this is the RTI viewer. I'll explain again how these images are captured, but the key thing is that RTI allows you to move your light source to overcome this problem of shadowing, losing information in shadow. So here's the main viewing area of the viewer, and in this corner we can zoom in on the area we're interested in. So I'm just going to zoom in, and you can navigate as you like. But as you can see, this is a very dark image that partly has to do with the low power of my infrared LED light source. But we can, and needing to not keep the shutter open too long because of problems of shake. And as I mentioned, stability is absolutely essential. So these are underexposed, but if we adjust the settings here, and we have these artificial rendering modes that allow you to enhance the surface in different ways. So these mathematical algorithms will allow us to adjust what we're seeing. So as you can see, this rendering mode called specular enhancement, it makes the surface look a bit glossy, but if we remove the color information and adjust these settings, bring them all the way out, then you can see more clearly what we have. The most important thing, though, is the ability to move the light, and so that's what this green circular area is, and you can grab the light and move it to whatever position you would like. So this is really a fantastic augmentation to just pure infrared, fixed light photography. Because now those problematic areas, unless the papyrus is curving over, completely, you can get light in where it might otherwise be. How you've got information lost just here in this deep sort of valley. But then when we move the light up, we can get in there and see if there's any text. Starting to pixelate a little as we're getting in so close, but you can see how, for example, there's actually a layer here. But if we move the light, let's see if I can pull it down. Depending on where the light is, it might be more or less apparent that you actually have text written across 2 layers. So you don't have a continuous line. In fact, you've got 2 layers there. We have a lot of layers adhering to each other in this area there. And when we compare this with the Brigham Young University images, in fact, it's much easier to count how many layers we have there. The projection with the data projector isn't as clear as it is on my screen, so you're welcome to come have a look afterwards if you're interested. But yeah, there's a lot more information to be gained here with this ability to move the light and to enhance these various to use these various enhancement modes. So just show a bit more. You can see how the layers, hopefully, is that coming up? Are you able to see, okay, that there are a lot of layers there when you pull the light in another direction? It's sort of lost. So very complex surface structures that we're dealing with. Now, as you can see, there are some unusual objects stuck into the shot here, and I'll explain if I can get this to, there we are. I'll explain what these are about in a moment, but this is the key to RTI, to doing highlight RTI, are these little reflective spheres, which you must put in shot in order to capture the position of the light. And it is that taking a series of photos, iteratively moving the light around, that information is captured on these spheres, and that allows you to process all those shots together and combine them into this kind of file where you can manipulate the direction of the light. We'll look at another example of the Herculaneum Papyri, but I want to say a bit about what reflectance transformation is. So RTI for short, it's a method of structured light photography. It's a kind of computational photography. Structured light meaning that you structure how you illuminate your target in a very specific way, and you record that in a very specific way. So digital images are taken of a target object, and this can be manuscripts, this can be all kinds of archaeological artifacts, lithics, botanical remains, of skeletal remains, what have you. If you have a question that's related to the material surface, you want to understand the material surface of an object, then RTI can be very good for fleshing out those details. So, but when you undertake these photographs, the target, your object must be fixed, and the camera must be fixed, whether it's in a, whatever your orientation is, you're shooting something on the ceiling of a cave, or tomb paintings, or something on the ground, or you just have your object on a table, what have you, that relationship must always remain fixed between the target and the camera. And then the illumination is applied from different locations. And with every time you move the light source, you take another photo. So these multiple captures are combined to produce an interactive, relit record of the surface, as you've just seen. This allows the improvement of visualization. It can also act as an archival record of the surface. So objects that are deteriorating, or for work in conservation, you're wanting to monitor the effects of vibrations, or surfaces out in the field that might be eroded, the next sandstorm comes through and that great rock art you found is going to be hammered with sand and dust, so you want to have a record of it. RTI is a very good way of recording those surfaces because you can get such high resolution images as well as capture more about the physical surface structure than a normal photograph. It's faster, lower cost than laser scanning, and sometimes you can't get the resolution as good, depends. So it can be seen as a method of preservation, and as I just mentioned, also a conservation tool. So it improves legibility as well as gives us more insight into physical structure, as you've started to see with the example I showed you. RTI has been around for almost 15 years now. It was first developed in 2000 by Tom Malsbender and his team at Hewlett-Packard Laboratories, and they published they first published it in 2001, and this work was on a mathematical algorithm called polynomial texture mapping. So there's another big mouthful to try to remember, but we call it PTM for short. But polynomial texture mapping is the method of fitting these photographs together. And let's see. Yeah, so it's available. The article is available online. If you just search Malsbender 2001 RTI, you'll come up with it quite easily, and then you can get a bit more understanding of how the technical side of it. Now there are several methods, several ways of conducting RTI kinds of equipment that you can use. The two that I've worked with involve a lighting dome, and then you've already seen a little bit of just a camera on a tripod. You can also use a light array on an arm, but the essential thing is that you are systematically applying illumination over your target surface in a hemispherical pattern. So you can use a lighting dome with lights affixed to the underside to do this. So I first started doing RTI in 2010 through a great postdoc at the University of Oxford, which was a collaboration with the University of Southampton, AHRC funded project called Artisad for short. And we built this, or I should say Southampton built this wonderful dome. We were trying to build a more portable system, so this one comes apart into 4 quarters, put it together with a bit of Velcro. You've got the camera attached on top here. It's a bit difficult to see, but there's a camera up here, and then you deliver the object underneath on a sort of scissor lift or on a, well, this type of thing here. In this shot, I have taken away 1 quarter so you can see the light, the LED light array inside. It had 76 LEDs. Again, the camera's up here. It's computer controlled, so once you, put it all together, put your object underneath, set the focus and exposure, and you also have a little curtain to block out any ambient light, because you just want the light sources inside the dome to be the only light source in each, the only source of light for each shot. This dome could do a full capture sequence in about five minutes, capture and processing. So that's great to have automated RTI for small objects, cuneiform tablets, coins, etc. But subsequent to this project, I started working on other object types that exceeded the size of the dome, or were in places where I couldn't always borrow the dome, take it. Yeah, it is sort of less portable, does have some restrictions. It's a much more expensive way of doing RTI, more systematic, but there's a cost that goes with that. So I started doing highlight-based RTI, and then I could go around happily to the field, to museums, and capture a range of objects. So this involves a fixed camera on a tripod, a handheld light source. So this is a little speed light here, Canon speed light, and using that to apply illumination around the target area. And reflective spheres. This is the real key. So here I've got 2 small resin billiard balls that are capturing the light position. So just to go into what highlight RTI is like a bit more. Highlight meaning that it's the manual method, that you're documenting the highlight from the illumination source on the sphere, so HRTI for short. Again, fixed camera, tripod, or copy stand. Target must remain unmoving, and a handheld light source. So you can see here, I think I'm at the University of Pennsylvania last year, imaging for the Magica Levantina project, a very fragmentary lead tablet. And I've got 2 spheres in shot, and I'm measuring the distance of the handheld light source from the target, and then releasing the shutter and manual, with the trigger rather. That's what I have in my left hand there. So that's to keep the distance the same, and then to ensure that the angle is correct. And you take about 36 to 48 exposures. Tethering to a laptop is optional, but advisable. And this image here is just to give you an idea of how the light is applied. So if you imagine your target object, we've got the setup here with reflective spheres in shot, ball bearings that you could pick up at a bicycle shop, as well as, I mentioned billiard balls, slightly larger objects. And I suppose you could use a bowling ball if you were dealing with some really large areas. But then just depends what the size of your target. And you want to apply light more or less on every hour of the clock. And from 65 degrees to about 15 degrees. So if you imagine we're here at 3, 4, 5, 6 o'clock. If we start at 3 o'clock, we do a high shot at 65 degrees of the light here, move the light down, take another shot, move the light down, and then at 4 o'clock, 5 o'clock, all the way around. Sort of give you an idea there of how you're applying the light. And once you've taken that sequence of shots all the way around your object, you then put it into a fitting software, where the software will look at the highlight and then is able to extract key information in order to merge all those shots together into the interactive file we looked at earlier. So hopefully this will give you an idea here of what a capture sequence looks like. So the light in this shot is quite high, moving down to a low shot with that nice low raking light, which is usually where all the good rich detail where it's fleshed out. Then again, high shots down to low shots. And actually, you can see I'm taking 1, 2, 3, 4, 5, 6 shots on each rib. And I was going a bit a bit excessive. My practice, I'll talk a bit about this a bit later, but I was influenced by the dome. The dome I had been using had 76 lights, but yet when you're taught to do highlight RTI, you really only need about 36 to 48 shots. But for whatever reason, I was thinking, well, isn't it better to have more shots? So I was doing more. It's not necessary. Depends again what your aims are, but it's really not necessary. It's a bit overkill. It's a lot of data to curate. Anyway, just to explain that. So this is sort of what happens when you take all your photos and you put them into the fitting software. It's called RTI. The one I've been using is called RTI Builder. It's built for Mac and PC. It's open access and largely open source, so freely available from Cultural Heritage Imaging's website. I highly recommend visiting Cultural Heritage Imaging's website. They have forums as well, CHI for short. Lots of information about all kinds of computational photography, but especially RTI. So what you do is you put your photos into this builder and you select the area where the sphere is, and you tell the software to find the round circular object within those pixels, and it will make its best guess using a kind of shape recognition software. You can adjust that, but it's important to have that be quite accurate, because that will give you the diameter or the radius of the sphere. Then you ask it to find the brightest, the center of the bright pixels within that circular area, and it will look for that and then mark it with an X. You can adjust that if there are any errors, but otherwise that information right there will give you the X and Y coordinates for that highlight, and then because the curvature of a sphere is known, you can calculate the Z coordinate. This here is just a blend showing how I applied the illumination manually. So you can see that the camera was at the top, that black area there, and this is probably the tripod legs might have been here. So that's why there's a little bit sort of missing, but otherwise I've quite well created that kind of virtual dome of illumination. And then the X, Y, and Z information is extracted from this point here, and then that's used to fit everything together. I'm not a computer scientist. I haven't been involved in any of this programming, so I'm explaining this in a very cursory manner, and I think there are other people in the audience who might be able to explain in more detail. Certainly reading Tom Malsbender and others' work on the technical side if you're interested in finding out more. And then once you're done with the processing, then you can view your result in the RTI viewer. And again, open access, so freely available, and open source. So you can play around with the code and add in features, and it's built for Mac and PC compatible, and you can get it on CHI's website as well. There are a few other viewers out there, but this is a very good one for a variety of reasons, which I'll go into shortly. So. This is a seminar format, and I just want to actually invite you to interrupt me if you want. I know this creates a slight problem maybe for the filming, but I can repeat the question, but I just want to make sure if anyone has any kind of questions at this stage or anything, any observations or anything to share? Okay, because I meant to say that at the beginning, that to sort of feel relaxed, and this is more of an informal affair, and if you have any questions, please stop me, okay? And I can, yes?
From what I understand, Cultural Heritage Imaging has done a really good job with the metadata of all of these different image files that you're creating and how, and the lighting sources and all that. Is all of this being archived on a routine basis, all this imaging, RTI imaging that's going on for going into digital repositories?
Yeah, it's a really good question. So the question was about the metadata associated with the capture and fitting, the capture and image processing, and to what extent is that data being archived with the images themselves. And so there is a mechanism for that, and you do get an XML file when you fit that shows the whole process and if any errors arise, and so you can actually check that yourself to correct any problems, and that should travel with the whole data set. And then also with the viewer, the same thing, you can output photos of what you see in the main screen, and there's a little, I think it's called a sidecar, that also has information about all of this information that in this newest build has been made visible. So you have the light coordinates, the X and Y coordinates for where the light is. You have the level of zoom, so we're actually over 100% here at 111. And then the pan. So the pan is, as you can see in this, down here is where we are on the surface of this. In this case, it's a wonderful wooden tablet, still with the wax intact, stylus inscribed. So that's, these are all the variables that you could recreate this particular viewing experience. Also the rendering mode. So you can, when you output a photo, maybe for publication for a blog or what have you, I don't think there's really a mechanism for attaching that. This is a problem with sort of publication, but at least you can access, that information is saved. And the same goes for bookmarks, which is a new feature. And this will sort of touch on what I wanted to talk more about at the end, about conceptualizing the image, not just as a resource, but as a process, as a practice, and that it sits in this relationship of activities, of decisions, and that influences the interpretive process. So bookmarking allows you to select areas and annotate, and I hope I have time to show a little bit of that when we get along further. But then again, all of that information all that kind of metadata is saved and visible in an XML document. So just to return to the papyri, now that you know a bit about how RTI works, and then the actual kind of pragmatics of trying to image these things, it was quite challenging because they're mounted on these wooden boards, and then they're further mounted on this kind of undulating paper that has moved and adjusted over time, over decades. I mean, these are very, even 100, 150 years. And then in turn, the papyri are backed on animal gut. So there's a lot there that's kind of could possibly move. As I showed you in the RTI setup, you need to place 2 spheres in shot. So I was having to kind of problem solve on the spot about how to do this. One thing, you don't want to damage the artifact as you're putting these metal objects. You don't want them rolling across the papyrus and taking out a section. So I was really worried about that. As you saw in that one shot, I actually attached the spheres to chopsticks and then kind of flew those into the shot. But the problem with that is that the highest and lowest point of the papyrus, your field of depth when you're focusing isn't that great. And so you might get the top of the papyrus and the spheres in focus, but maybe not the lowest part of the papyrus. So I was really struggling, would I have to do a high focus shot, a whole sequence, and then do a low sequence, while also maintaining a high enough quality spatial resolution. So these were the kinds of issues I was trying to negotiate. So thanks to some very kind engineers at University College London, I took them some ball bearings and said, guys, can you cut these? They were all guys. And said, can you cut these in half? And they all gathered around and scratched their chins, and they were like, we're going to put our eye out, trying to hold this thing in a machine so that you can actually that it could shoot out. It could really be kind of a dangerous undertaking. And they said, well, leave it with us, and we'll have a think. And they came up with a method, and they actually shaved down some ball bearings for me. And so these are them right here. And that was great because what it did was it reduced, they're truncated just to the point where the original diameter is still preserved. You don't want to undermine, you need the real diameter because there's a relationship between the radius and the curvature. So that must be still intact. So they were just a little bit larger than hemispheres. But that was great because that meant I could lay them on, they wouldn't roll around, I could put them on they weighed less, so the chance of them causing maybe the paper to sort of relax while I'm undertaking the capture sequence was reduced, and then they're just lower lying, so it was easier to get them in focus with the top of the papyrus as well. So there are, each object type presents its own challenges, and you've sometimes got to think around how you're going to sort out these kind of very basic problems. So still working on that. They told me it would cost a lot of money to have more of these reproduced. This was just for a bottle of wine, but apparently it will cost over £100 to get more produced. And we want to do more imaging with the papyri. So anyway, that was a really good, happy solution. Yeah, I wanted to show you one more example. So if we can turn the lights down again, just to kind of show off these great annotation features. So we've zoomed in a little bit. I'm going to put on the specular enhancement rendering mode, remove what's called diffuse color, and then these are already monochrome actually, because I've converted them from the kind of pink infrared images to just monochrome, but that setting is probably the best. So for example, if we're looking around for problematic areas, and let's say someone has got one of the old infrared shots and another scholar said, hey, I see that actually this sign it's on 2 different levels. So you want to send this off to a colleague to check, to verify. So you can actually click on the bookmark function and you can add a bookmark in theory, there we are, and say, letter onto layers. I mean, you know what it is, but you're just wanting to, yeah. So here you can add a highlight box to sort of indicate the area that you're focusing on. Update the bookmark. Maybe you want to add an annotation. So this can be about layers. Oops, layers. Check this out. Make whatever note. And then that's all available to go to whenever you can send the file off with the XML sidecar, and that will be available to anyone else to sort of look at what you've annotated about that particular area. So you can go back to, say if you've just opened the file, back to just opening the file, and then your colleague wants to open it, they can go to your bookmark and immediately you're taken to those exact viewing conditions. And this is something that is really exciting because these are the conditions that have been so difficult to reproduce. We've just had to take it on faith and someone's sort of reputation and what have you, that what they see is what they say they see. So in this case, you can reproduce these critical aspects of the viewing experience: the light position, the rendering mode, where exactly you are on the papyrus, the position of the light, and the level of zoom. So this adds a whole new layer of rigor to the examination, the process, the interpretive process, which is very, very exciting development. Yeah, so the infrared RTI has a, I hope I've showed how it's really addressed these previous shortcomings. It's the increased contrast, which the IR provides, combined with clear representation of 3D shape, is a real advance on the fixed light photography. Being able to clearly discern the holes that I mentioned that can be confused with ink. As you move the light around, it suddenly becomes very apparent that you are dealing with the absence of papyrus. So that's quite clear. Being able to distinguish layers with greater precision, to count them, to discern these bits that might be stuck, that have come from before or after where they actually belong, the sottoposti and sovraposti. Also, the RTI allows you to see into the shadowed areas where data might have been lost otherwise. And then the artificial enhancement modes. And then just overall a better understanding of the written content as it relates to the physical structure. So this has been quite an exciting and positive result from these pilot tests. And we are currently, let me just check my next slide. Yeah, currently preparing a funding bid with the University of Oxford, Cologne, and Naples to try to take this work forward. So we hope there'll be scope for addressing the rest of the collection. I just wanted to say a bit about supporting the research process, because so often we will digitize things, but not with a lot of conversation with the users. And the Herculaneum Papyrologists, they sort of define 4 areas of work, of their work: the discovery process, which is largely done. There's still more to excavate. There might be more papyri to discover. But then there's the preservation work, the editing and interpretation. This is how they define it. So RTI contributes to these aspects by providing a method of preservation effectively, because these things are sort of degrading. Every time they're pulled out, they're bumped, bits are falling off as the temperature changes, etc. So good documenting these objects well can provide a method of preservation. Also condition reporting and monitoring how they change over time and with use. But importantly, RTI is also going to add another level of rigor, of systematicness too. That's the word. To make a study more systematic by improving legibility, making artifactuality clearer, and the analysis process more robust. So documentation of the research process using the annotation tools that I very quickly gave you a taste of. So how much more robust that research process is. So it's replicable, and you can sort of trace maybe where errors occur and rethink conclusions that your colleagues have drawn, because you can see how they've built their hypotheses. So that's all very exciting. The next thing I wanted to report on was the Magica Levantina project. This is the project dealing with Greek magical texts. So this is with Robert Daniel at the University of Cologne and Alex Holman of the University of Washington. And their aim is to edit a volume for Papyrologica Coloniensia series on Greek magical texts from the ancient Near East, including Cyprus. And this work actually began as a collaboration between, Topoi really, and Cologne, because I was still based here with my Marie Curie Co-Fund Fellowship and had an extension through Topoi, and Cologne didn't yet have their own RTI kit, and I had assembled the system here at Topoi. So FYI, they're at Topoi, we're in the DIE, but there is a full RTI kit over in Topoi that can be checked out and used. So I was using that to undertake the RTI for Cologne initially while we were getting funding together to get Cologne's own system. So it was great to have support, here in Berlin for getting this work off the ground. The focus of Magica Levantina is on unpublished curse and protective magic, inscribed on lead, selenite, silver, and gold. And these come from a range of sites in the Near East and are located or curated in a range of collections in the US, Europe, and the Middle East, in Israel. So I've been going around to all these collections over the last year and doing loads of RTI till I was cross-eyed. It's very, very exciting though to get to work on all this material. Simply fascinating. And you can get an idea of the kind of material I was working on, these lead sheets that were once inscribed and then rolled up and then placed in various locations as cisterns and baths and under turning posts and racetracks and all sorts of places. And then they've been discovered and unrolled, sometimes for better or worse, not always in great condition, so you get some very fragmentary material, often highly corroded. Sometimes they've been cleaned before I work on them, sometimes not, so it can be quite difficult to really see what's on the surface with the naked eye. So some of the, so again, I was trying to, so we wanted to image these tablets using RTI, but of course Bob and Alex and other people working on these texts already have a way of working with them, under the microscope, holding them in their hands, rocking them back and forth, having needs in terms of things like script size, being able to move the light and negotiate the surface complexities, seeing things, that are tucked under pieces of bent metal and what have you. So I had to really try to think about how I could meet their needs, not create something that's too unusual, it fits nicely into their workflow, and addresses their present priorities, but also opens up future possibilities, because I, as an Egyptologist looking at the materiality of text and image, I'm very interested in these things as material objects. And Bob and Alex are more interested in the meaning content of the texts. And often, we'd have conversations like, well, just imaged all the front sides, of all the tablets. And I would say, well, actually, we really should image both sides because we don't know if there could be meaningful information there. Sometimes there are inscriptions on the verso, on the back side. And sometimes they're just interesting marks that have to do with use, with the way the lead was put together, marks of production. So I was sort of pushing a more kind of holistic approach, but so that opens up future possibilities because I've undertaken a more holistic imaging workflow, but their present priorities are also being addressed. But you can see from the image on the right that these are not easy to work with. The object is very curved, so inevitably part is going to be in shadow, part in light. So having the RTI is a great boon. But yeah, some signs are very small, and they want to be able to read them 3 to 4 centimeters on the screen. So I was trying to image at a spatial resolution that would allow them that kind of result. This is not well focused, but hopefully you can see how fine these marks are and how difficult they are to read. So there's Alex having a look under a lamp. And this is the kind of viewing experience that I wanted to try to recreate for him with the RTI results. So this visual perception, the main problem is the environmental condition having to do with light and its control. So light often is fixed, or even when you're trying to move it manually, it's quite difficult to get it in the position that you want. And also the angle, the angle of incident, and then also the intensity, how bright it is. So being able to control these particular aspects of the conditions of viewing is a really important thing that RTI brings to this work. So here is a wonderful lead tablet that came into my hands last year, had just been excavated from Jerash in Jordan. It was unearthed during salvage excavation of some cave tombs. There's not a scale in this shot, unfortunately, but it's about this big. It's quite a large tablet. And rather than being rolled, it was actually folded up. And it's not very flat. It's really full of valleys and peaks. It preserves 37 lines, and it's almost all complete, as you can see. And the letter height was about 0.7 centimeters. So I ended up shooting it in sections, in four or six sections, I forget, to get a good enough resolution for Bob and his students to be able to work on this. So here's just a close-up of one section of the tablet. But if we can have the lights down again, I can just show you now what the RTI reveals for lead. So you can't see a whole lot at this stage, but if we let's go back to Navigator there. So if we zoom in, let's say here, move the light around, you can start to see a bit more clearly. So this is kind of the experience you might get with visible light, but the power of RTI is fully revealed when let me see, I gotta move this, it's a bit too bright. But there, if we put on the specular enhancement mode, it really brings out the strokes in nice detail. And you can start to make out the details of ductus. You can see which lines cross over which others, which lines cross over others, and even how the stylus or the tool is being wielded. That you've got this, this stroke coming down and then sort of tapering off. You can almost see how the scribe is moving his or her hand as the stylus is pulled away from the surface. And you can start to really see, the rhythm and the practice and great paleographic detail. And of course, Bob's aim, Bob and Alex, to read these and understand more about what they say about magical practices. I don't know if you've already gathered, being an Egyptologist and not having taken Latin or Greek, I actually can't read and enjoy the philological and literary side of these objects, so I have to consult Bob for things like meaning content. So this is what he prepared from the translation that he and his students have been working on. So this tablet, it was created by or for a woman called Irene, I think you would say, also called Flavia, wife of Lamiros. And she calls upon you, gods, so that you subordinate. And then she lists some 30 names and then says, hear me, Lord Abrasealoa, I might need some help if anyone wants to volunteer. Abrasax, Pekafi. Yea, Lord God, subordinate to me, Irene, also called Flavia, the whole household of Lamiros, slaves and free persons, and all the aforementioned. Most of all, Lamiros, my husband. So she's really going after her husband for some reason. Bind down the mouths, tongues, wrath, anger of the aforementioned, so that the aforementioned on this plaque may in no way speak against or act against me, Irene, also called Flavia. So she's trying to shut up her whole household and bind them. And then some lines later, she says, you demons reposing here. And I assume that's where it's been deposited. I need to ask Bob. I'm traveling ahead of the sun, appear in the form of frogs who have filled up their mouths with water and spit into the mouths of the aforementioned, most of all, Lamiros. So this is what this particular tablet deals with. And yeah, Bob thought maybe she took the credit card and went off and bought like loads of shoes or something and was really worried about getting in trouble for something. She's done something, and she's very concerned that it not be revealed. And she especially is fearful of her husband's wrath. So that's what this wonderful Jerash tablet deals with. And just to show you another lead tablet, so we can bring the lights down once more. This is one that's in, I don't have anything about the content meaning, but just sort of one that's a bit flatter to show you. There are a range of rendering modes, and depending on the object material you're dealing with, you might want to use different ones. I'm not sure if diffuse gain will really show as much. This sort of accentuates fine lines and can be helpful. Now we're starting to pixelate, but it's really the specular enhancement that really brings out the most on these kinds of objects. So you can really, even if there is some corrosion, the light, you can still pick up the edges, the contours of shapes of letters, and things can still be legible. There was a Mandake lead scroll in the Ashmolean Museum in Oxford that was considered illegible, and then I did RTI on it, and with this setting you were able to you could read what was below the corrosion. Just enough of the contours could be fleshed out. So that's quite nice. Okay. My last example deals with the other type of cursed tablet that I've been working on. These are the Selenite Tablets from Cyprus. They're thin sheets of gypsum or talc. They're inscribed in Greek also from the site of Amathos and date to between 300 and 500 CE. There are 25 in Paris and about 100 fragments in London. So you can see here in Paris and then in London what these things look like. They're very fragmentary. So our aim was to document them more fully, to improve readability, to also virtually reunite the corpus, which is split between these two collections. So we're looking for possible refits, and then also to make this as a resource available for other folks. So as you might be, well, Gabriel Baudard has been working on this previously and very generously donated some of his data to us to get started on this. So these hopefully be a resource for other projects as well. Just a couple examples of them as they look as reconstructed. You can see it's very difficult to see what's inscribed on the surface. So they're notoriously difficult to read. I've repeated a slide, excuse me. Okay, some information. Very difficult to read and also quite difficult to image. So the surface wear and deterioration is part of the problem. There are bits stuck on the surface. They're almost see-through. Some of them are almost like glass. They're also very reflective, highly fragmentary, and they flake off sort of like fish scales. So they're very difficult to work on. And you can see Bob staring down the microscope there in Paris trying to read these things. And here's an example from the BM. So I'll just show you an example of the results. So here's one from the British Museum. I'll just zoom in a bit and move the light around. Let's see, specular enhancement. So I've got the light too low, I'll bring it back up. So you can start to see how different they are from the lead tablets. But nevertheless, it is possible just to make out the inscriptions, but a very different scribal practice. You can see how the stylus is sort of scratching and jumping along the surface, but you can still make out where the final pressure, the end of the stroke, so you can get some of that nice scribal information. So that's the kind of result we're getting on the Selenite tablets. So I tried backlighting them. I tried a whole range of different techniques to see what would be the best results. And I did have a problem where the background I was using was a fabric, and where they were quite see-through, that fabric was coming through and interfering, creating a pattern that was disruptive to their readability. Those that were more opaque, that was less of a problem. So I had to end up going out and finding, I did a series of tests on backgrounds to find out what would really provide the best result. So trying, matte card and gray matte, and of course the shiny black card ended up being the best backing for these. Backlighting them just washed them out. So there was a bit of trial and error in trying to get a good result initially. I'm running short on time, so I'm going to move a bit more quickly now. But I think I've sort of demonstrated now quite well how RTI addresses previous imaging shortcomings by overcoming problems of translucence and specularity, specifically with the selenite tablets, capturing sign edges even when corrosion is present, so for like lead, clearer discernment of scribal technique in relationship to material behavior. So the lead is sort of, you're impressing it and pushing it aside, while the selenite is sort of flaking off. So that affects the appearance of the signs. And the increased certainty for virtual reconstruction for the selenite specifically, to see how edges might fit together between the two collections. But then again, just supporting a more robust analysis and documentation of the research process using the RTI viewer annotation tools. And that was kind of the last thing I wanted to talk about. And I might not have as much time as I would like, but was to get some feedback from you about, we often treat images as sort of passive, static objects, but in fact, RTI has really made clear to me how active and mediated or mediating and situated images are. That we have, in the course of experiencing these surfaces in these different ways, we can see that the way an image behaves and the way you engage with it provokes new questions and raises new problems. And as you're able to share that viewing experience, not just a static object, then you can, with your colleagues, create new and more advanced or complex hypotheses. And hopefully all of that kind of information about the not only the capture process, but the viewing and interpretive process can be metadata that supports the archiving of that, potentially even citing it in publication ultimately. That's something we need to kind of overcome. But I'm really trying to conceptualize digital images not just as results, but also as practices, and as situated in practice, as processes and outcomes of processes. And that's something, if a little self-promotion, if I may, I had been really working on in my research previously, my doctoral research, up until I started working heavily with RTI. I was trying to understand past art and writing as a material object, so how past scribes and artisans were working. And now, as doing a lot of digital imaging myself, trying to understand my own process in relation to users and all of us out there doing documentation and processing and using these images to think beyond just the artifacts being bound up in this interpretive process, as Segel Lintart has stated, in order to convey knowledge. It's treating them as resources, but something she's also looking into, and others are, how they are informed by this whole Chenin repertoire of research questions guiding the lens of the camera, the kind of equipment you choose, the capture process you select, with a dome, with a fixed camera on a tripod, the way in which the image is processed. And then you have this product, and then I hand it off to my papyrologist, and he disseminates it or uses it in various ways, but to really try to see the images situated in this whole network of relationships. So just to kind of emphasize this further, like which capture and processing variables should we document? I've tried to keep close, more to annotate more fully my workflow, and you start to lose a lot of time, in terms of getting actual work done. but sort of observing how my practice has been influenced by my first working with the dome and then having to work alone because I don't have funding for an assistant, and how I'm having to develop a single operator workflow. But then also being a researcher myself and working quite closely with other researchers and understanding their needs, that starts to then inform back into my decisions about which lens I choose, which resolution, the image file type. So kind of connecting up all these dots as well. So we do have, RTI practitioners do use a shooting log and do keep some information in that. And then Cultural Heritage Imaging is developing a lab notebook to try to bring this data together. But it does present, for digital humanists, digital classicists, I think this does kind of present an ongoing problem of how we both document the process as well as just focusing on the outcome of that, publishing a book. But how did we get there? How did we get to those illustrations? So there has been work going on, second to last slide, looking at this wider sort of working area with text scholars, looking at the interpretive process. So Melissa Terrace has been working on this, as well as Ségolène Tart, and others, but it's the kind of artifact digitization area and image processing area that I think we can unpack and look at how that influences the whole text interpretive process as well. So there's room for work to be done, and I'm interested to hear from you perhaps other facets of that part of the endeavor that need attention. So, excuse me, yes, a couple others are doing work on this problem. So there's still much scope for moving beyond the notion of images as resources and situating them in these network of relationships. But then the problem of how we sort of communicate that within our digital practices. So my final slide to sum up. I've tried to demonstrate tonight that RTI offers a powerful tool for documenting and visualizing text objects, such as carbonized papyri, and then these curse tablets of different materials. How RTI emulates physical interaction with the object, improves legibility, emphasizes material features, provokes this multisensory engagement, which in turn raises other new and exciting questions. It allows for the transparency and replicability of the capture process, the viewing experience, and conditions of interpretation to some extent, but also fosters a critical awareness of digital images as processes. So it's on that note that I would like to end, and it just leaves me to thank a range of people for helping make this work possible, and then to thank you this evening for coming and for your attention.